Okay, guys, I'm back. I hope you're all there. Any questions before I discuss how this actually bird is prepared? What are the fundamentals of extrusion-based systems? I will discuss all these in a moment and in this hour and next hour. But if you have questions regarding project topics, we may discuss a little bit, and then I can jump to this Cura software once again. Any questions? So I think everything is clear about the project topics. Please don't forget to submit your selections. Send me an email till tomorrow midnight. Okay, you see this is the Cura software I showed you in the previous week, as I remember. I'm not showing you all the things once again, but we can briefly go through it. This is the STL file of the bird I imported into this software. This is my building plate, and you can also see it on the printer. And then I have done some settings. The layer thickness is 0.2, and we know that additive manufacturing mostly depends on layers. So the software actually performs slicing. So it slices the STL file, obtains contour of each layer, the outer profile of each layer, and then determines the interior pattern according to your settings. Now let's jump to this layer view. You see I use triangular interior. I'm using infill pattern as triangles, and my infill density is 25. So which means that 25 of the interior of this bird is actually filled with material. And I have other settings like line count. There are 2 lines. That means there are 2 shells. If you carefully look at it, we have 2 shells at each layer, and then the rest is filled with these triangles. There are many settings you can play. These are things I have done, and I will show you that this is an extrusion-based system. So in order to extrude, we need to heat the material. We need to increase the temperature of the material, and in this configuration, the temperature of the material is set to 205, and the temperature of the build plate is set to 60. I will talk about in a moment why it is increased. And we have 100% flow, so it is flowing at the desired assigned speed. We may increase it, but this is fine. We have some options for the manufacturing speeds or fast travels. We may modify them, but these are some default settings. I want to spend some time on support. Let's switch to this view here. As you can see that underneath we have support structure. Since we don't have a flat surface underneath this bird, in order to connect it to the ground, we have these support structures. And also to the mount of it, we need to use another support part. You see here, this is a support structure for the mount of this bird. Yes, we can use water-soluble supports, and I can maybe discuss it while I'm on the machine, but we can use that. Right now, I am using the same material for the support. But if you have a different material installed, for instance, on your second extruder, like water-soluble support or easily removable support, then you may select the second extruder, and then it will generate. Now, in a moment, we will see, I think, that the supports are in different color. Okay, it's about to show it now. No, processing. Yes, here we go. As you see, the supports are now made of a different material, and this is possible with this machine since I have 2 extruders. One extruder may extrude the white material, which is the main material, and the second extruder may deposit a different material. And in this configuration right now, let me show you, as that should be here. My second extruder is selected as black PLA, but if you have installed different patterns, different materials, then you should select them. For instance, there are special materials for breakaway, and these are for support structures. They can easily be broken, or you may use PVA, natural PVA. It is actually the material which can be dissolved in water. And for instance, this shape, I have done it. I have printed this one by using this PVA material, water-soluble, dissolvable material. And with the help of it, you can obviously fabricate much more complicated products. Since if you use the same material or other PLA, it will be quite complicated to remove the support structure from the interior regions of your part. But if it's water-soluble, things are simple. You throw it into water, and then it will be dissolved itself. Just you need to wait some time. Another issue I want to talk about is the brim or the build plate aeration. So this was our build plate, and the first layer is the most important layer in additive manufacturing technologies, since you need to have a connection with the build plate. And if I don't use, for instance, in build plate, then I will have less contact with the build plate, and it's highly probable that in the upcoming layers, once you have some forces, some torques, moments on your structures, your bird may be removed from its original position, and since it's not a closed-loop system, your machine will not realize whether something is wrong and your print will fail. So in order to increase the quality of my adhesion, what I do here in this example, I have brim type of build plate adhesion. There are different types, like skirt. Skirt is just moving, extruding kind of an outline. Let me switch to that and show you the skirt, but it has not much importance in terms of your adhesion to the plate. It's just for cleaning the material. Now it's processing in a moment. Yes, you can see that we have a little material in black here. This is called skirt, and as I said, it's only used to clean the material at the tip of your nozzle, but it has no importance in terms of sticking your part to the build plate. And if you remember, I said that we are setting the temperature of this build plate to some high levels. This is 60 degrees for the selected material. With the help of it, actually, again, we are trying to increase the probability of our material sticking to the plate. If you don't use a hot plate, then you may have difficulties in the first layer and your part may not be stick to the plate. Another option we can use is the raft. It's very similar to the rafts actually we are using in rafting. There are some settings about raft. So we have a kind of a raft or structure underneath. Again, it's better, but the best one is the brim. Then comes raft, but skirt has no importance, no actually advantage in terms of adhesion. As you see, this is our raft. Now I will jump to top view. I'm sorry, guys. This is now okay. Yes, this part is actually this first layer is the raft, and then on top of this raft, we increase the actually density of these rays, decrease the gap between these vertical lines, and have a proper workpiece. So these are all actually invented or let's say generated to have proper prints, high quality prints on your 3D printers. Any questions, guys, regarding these issues? I may switch to the 3D printer. Now you see this is the build plate. It's quite hot, about 60 degrees. I cannot keep my fingers on it a lot. And at the beginning of the printing, it extrudes, deposits some materials to try to actually remove any dirts or any other issues available at the tip of the extruder. After this part is extruded, then it starts the first layer. You can see, let me try to move it in this configuration. You You can see the brim there. You can see support structures. Now the interior of the part is being built. We have triangular patterns. Let me show you from here once again. You can see that we have a separate, let's say, support structure here. And this is for, if you remember, for the mouth of the bird. And underneath we have many support structures. These are called as accordion type of support structures. After the part is finished, I can easily remove them. Another things you can do, actually, you can change the, by using, let me show you the screen. First, you may modify your print while you are fabricating a thing. You can stop it, obviously. You can change the printing speed, for instance. Right now, its speed is 100%, and I will, for instance, set it to. Now you can hear that the voices change. Now it's printing in a much more slower way. Now I can adjust it once again to 100%, or you can even increase it to more than 100%. But then probably the quality of your print will be decreased, so I will again keep it as 100%. Then you may adjust the temperature of the wheel plate, but it's better you don't modify it, since otherwise if you decrease it, then probably your part may be removed. You can adjust the fan speeds. Fans are highly important. Let me focus on to the head now. So in this extrusion systems, the head is actually the everything of the 3D printer. It's responsible for extruding the material. Inside this head, we have a kind of an extruder. I will show you the extruder, the same extruder in a moment. And at the back side of the 3D printer, we have a spool of material. I will bring you an example. So at the back side, I have such a spool of material, okay? It may be any color in material. This is PLA, and also I'm printing in PLA. It's at the back side, and with the help of an extruder, we have an extruder motor there, and it's actually squeezing the material and then extruding it through this nozzle. Now I will try to rotate. I hope it's not going to stop. Actually, here we have the extruder. Yes, this is how actually material is supplied to the head. This is our spool. I think it was about 1 kilogram of material. We have an opening here, so we push our material into here. And we have a gear and a pulley there. With the help of this gear and pulley, the material is squeezed and then is pushed upwards. Since we have a stepper motor here, I'm not sure whether you can see the shaft of it, but it will be quite difficult. So assume that we have a motor here, it's moving this material through these tubes so that it will be fed into the head of my 3D printer. And then what happens in the head is that since we have a little opening, we have a nozzle there. Now let me move this camera here. Okay. At the head, this one actually has 2 nozzles. And your nozzles may have different diameters. For instance, the one I have in my hand has a diameter of 0.25 millimeter. So you can, it's quite difficult to see the tip or the opening of this nozzle. Right now, 0.4 is installed, and we are printing this bird with the help of 0.4. So what happens there? we are feeding the material into here, and then it passes through this channel, and at this yellow part, we have a heater. So we have connection here. This is electric connection, and we have a kind of a resistance inside. It is heating this little chamber. This little part is temperatures, again, as if you remember, we set it to 205, and we check it by this thermocouple. We have a temperature sensor. We are always checking the temperature and trying to set it to the desired value all the time. If you change it, for instance, during the printing, then the quality of your print will be decreased. So your controller, your temperature controller should be as good as possible. And then if you look at the above part of this channel, we have kind of fins. Since we don't want actually our material to be heated in the upper regions. So we just want it actually to be heated, or its temperature should be increased only around here. Since otherwise, if its temperature is higher around here, then probably it will be melted and we may not be able to push it. Since we are extruding it through this nozzle with the help of mechanical means. So we are pushing it, we are applying force on it. But if you increase the temperature of it around here, then it will be quite softer. Maybe it will be in a bit liquid state, and once you apply force, you cannot extrude it through this opening. So that's why we have such fins to decrease the temperature of your filaments from this point above. So it's not complicated, as you see. We have just 4 cables, 2 for temperature reading, 2 for giving energy, giving heat to this nozzle. And with this little chamber here, this little yellow thing here, we increase the temperature of our material in less than a second, and then try to extrude it with the help of force we are applying from the back side. Since at the back side of this printer, I said that we have an feeder. A feeder is actually composed of a pulley and then gears. So while they are rotating, they are feeding this material above, and the amount of material you are feeding is highly important since it affects the amount of your extruding at the tip of this extruder. So they're highly related to each other. And we have another important issue, that we have some fans on this head. We have one on the right-hand side, one on the left-hand side, and one at the front here. They are responsible for actually cooling the material which is just extruded. So we don't want actually our material be in semi-liquid state once it's extruded, since if it's a semi-liquid state, then it will not be able to retain its shape. You have weird, let's say, materials, extra materials on your surfaces, and your product will not be the one you're looking for. So that's why this cooling is highly important once the material is just deposited. Any questions, guys, about these fundamentals? Oh, okay, there were some layers, some questions, but I couldn't read them. Let me check them one by one. So there's a question about the thickness of the ref layer. You decide according to your experiences. For instance, I rarely use ref, so I don't have much experience, but it's better you don't increase it too much. It's better you keep it as low as possible. Dennis, what do you mean by the chamber? Do you mean this building chamber, or do you mean the chamber, the yellow chamber here, or the interior of this one?
Hocam, you showed it,
okay.
As you showed, it's a filament.
Okay. Yeah, Boran has a question about different material. We'll talk about it. Yes, depending on the type of material you are using, you need to change the temperature of the build plate to different levels, or change the temperature of the extruder to something different. Maybe for instance, we are printing these days polyamide with some carbon fibers inside, and I'm setting the nozzle temperature to 260 degrees, and I'm setting the base plate to 110. So depending on the material, depending on the content you have in your material, you need to use different settings. Even you need to change, for instance, the temperature or the speed, some other things, parameters. So they all depend on the type of material you are printing. Open filament system means that you can use any kind of filaments. For instance, Ultimaker has a kind of a system, but some bigger companies actually don't want you use different materials, cheaper materials, since they have optimized their printing quality according to their materials, so that they don't want to use cheaper materials or materials of other companies. So this is something politics, so you decide on it. But the one right now you see has an open filament system. We can use any kind of materials. Any other questions, guys, about the printer? I can maybe tell about you motion. So it's a 3D printer, which means that we have motions in 3 axes. Obviously, this wheel plate is moving in Z, and this motion is provided with the lead screw here. And underneath this machine, we have again stepper motor. And once it's driven, it moves this table upwards or downwards. And we know that after each layer, you should be moving this layer to an amount equal to the layer thickness. So if your layer thickness is 200 micrometers, then after each layer, this table should be moved just 200 micrometers. Then we have 2 other axes, X and Y axis. You can see the belts there, and we are again using kind of stepper motors here, one here, and the other one is here. So with the help of them again, you can provide such a motion on the XY plane and try to fabricate that specific layer. And in order to decrease actually the cost of these motion systems, such desktop printers are only using open loop systems. So they don't have actually kind of a measurement on this axis. They only say that the stepper motor should, let's say, rotate this amount so that it will go to 15 millimeters. But they don't check whether the head is already there or not, since they are using stepper motor and they are using timing belts and they are using gears. So they are assuming that there will be no actually mispasses, or they will not lose any threads, and the head will always be at the desired position. But for high quality systems, you may use much more complicated drive systems, servo drive systems, closed control systems, so that your accuracy might be much better. And actually, the one we are using in the machine in the manufacturing, in the smart manufacturing lab, is a closed system. We're always checking the position of the head. That's why actually the quality of our surfaces are a bit better than the quality of this 3D printer. I think these are all I can say about this printer. Any questions, guys? There's a question about the closed printers. Boran is asking whether do we have an advantage if we close the whole environment. As you see, this is open. Above is open, the side is open. If you close it, then you may have more control on the temperature. And for some specific materials, especially some types of composite materials, the interior temperature is highly important. But if you are using PLA, then you don't have any worries about it. You can easily print it. So that's why actually I prefer to use PLA for most of the time. For other materials, things are highly complicated. You need to set the temperature to very high levels, the wheel plate temperature also. You need to set the temperature of your nozzle again to maybe around 250 degrees. But if you are using PLA, things are much easier. Another advantage of PLA material or the polylactic acid is that it's biodegradable. It has not much actually harm on the environment. So I print PLA about 90% of the time. But once you have a closed chamber, then that means you have more freedom in terms of material variations. You may print different materials easily. Are the parts of these machines made through AM as well? It's possible, but they haven't done it. But there are some companies, organizations, I think you're already aware of that, replicating type of printers. These are possible, but Ultimaker didn't use, even they have very simple products. For instance, they have a kind of an extruder changer here. Since we are using two extruder, once actually the printer wants to change the extruder type, then it comes to this point and changes its extruder by moving one downwards and moving the other one upwards. And even they have fabricated this one using injection molding, but not 3D printing. So Ultimaker is not doing such a thing, but it's quite popular in 3D printing community. They love to print actually parts of the 3D printers using 3D printers. And as you, friend, pointed out, it's a replicating printer, self-replicating.